today discuss frequency modulation. Okay, which is denoted by FM, means frequency modulation. This is the types of angle modulation. We discussed the angle modulation earlier. Okay, these are the types of angle modulation. Second is, this is non-linear modulation. Why it is called the non-linear, we discuss later. Okay, next, the frequency modulation, the amplitude and phase are constant, but frequencies vary. Okay, so frequency modulation is the type of frequency modulation is the type of angle modulation, and this is a non-linear modulation. And third is, frequencies vary but amplitude and phase are constant. Okay, so what is the definition of frequency modulation? Frequency modulation is that type of angle modulation. FM is that type of angle modulation in which the instantaneous frequency is vary with a message signal, which is denoted by xt, on unmodulated carrier frequency fc, means omega c. Okay, which is fc. So frequency modulation is type of modulation in which instantaneous frequency is vary. Whose instantaneous frequency? The carrier instantaneous frequency is vary according to the modulating signal, which is same definition as amplitude modulation, where amplitude is vary according to the modulating signal. Here the instantaneous frequency is vary according to the modulating signal. This is the difference between AM and FM. In the AM, amplitude is vary, but in FM the frequency is vary according with the modulating signal. But phase and amplitude, okay, phase and amplitudes are constant, where phase and amplitude are constant. So the instantaneous frequency is denoted by omega. So instantaneous frequency is denoted by omega I. Omega I is equal to omega c plus 2 pi kf into xt. Okay, the instantaneous frequency is the sum of carrier frequency and time varying component of, this is the carrier frequency. Okay, this is the time varying component of message signal, which is denoted by xt. This is the time varying component. So the instantaneous frequency is the sum of carrier frequency and time varying component of message signal or modulating signal. Okay, actually the omega I and omega c is called the angular frequency. Omega I and omega c is called the angular frequency. If we convert in frequency, is denoted by fi is equal to fc plus 2 pi kf into xt. This is the frequency component. Okay, the instantaneous frequency is denoted by, means in omega, because we know the omega is equal to 2 pi f, means in the omega the frequency is present. This omega is called the angular frequency or angular velocity, and f is called the frequency. So the frequency equation is instantaneous frequency. Fi means fi is the instantaneous frequency, means instantaneous frequency means at present frequency. The frequency is vary, means frequency is vary time to time. So at this time the frequency is called the instantaneous frequency. When the time is increase, the frequency also change. So at this time the frequency is called the instantaneous frequency, means at the right time the frequency, at this time the frequency is called the instantaneous frequency. Okay, so let the message signal, xt is equal to Vm sine omega mt plus phi m. Okay, and carrier signal Vc is equal to Vc sine omega ct plus phi c, where Vm and Vc, this is Vc, means instantaneous value. Which value? Carrier value. Vc is maximum amplitude. Okay, omega c is the angular velocity, which unit is rad per second, radian per second, and phi c is the phase angle. So for modulating signal, a Vm is the maximum amplitude of modulating signal, omega m also for angular velocity for carrier signal and angular velocity for modulating signal, and phi m is the phase angle of modulating signal and phase angle of carrier signal. Here the amplitude and phase is constant, so the equation becomes xt equal to Vm sine omega mt, and carrier signal Vc is equal to Vc sine omega ct. So instantaneous omega I is equal to, previously we noted that omega I is equal to omega c plus 2 pi kf into xt. Okay, put the value of xt. Okay, so omega I is equal to omega c plus 2 pi kf. Xt means modulating signal, which is Vm sine omega mt. So this is Vm sine omega mt. In angular modulation we also discuss omega is equal to omega is equal to d phi by dt. We also I discuss in angular modulation chapter. Omega is equal to d phi by dt. So from this equation d theta or d phi, which is d theta or d phi. Okay, so from this equation we get the theta. From this equation we determine the value of theta, which is integration of omega into dt. From this equation we determine the value of theta, so integration of omega into dt. Basically this is the omega I, so this is the omega I into dt. So theta equal to integration of the value of omega I, put this value omega c plus 2 pi kf into Vm sin omega m t. Okay, so this equation is integration. Okay, so omega c is the constant term into dt, so omega c is the constant term, so omega c into t plus 2 pi kf Vm sin, the integral part of the sign is called cos, so cos omega mt by, with respect to omega m, so is divided the omega m, so we divided the omega m. Omega c is the constant term, so this is the omega ct, and 2 pi kf is the also a constant term, so in a constant term the integral value is same, so Vm sin omega t, Vm is also a constant term, and sin omega mt, integration of sin omega t is called the cos omega mt and divided by omega mt, because we respect the integral with respect to omega into dt. So omega ct plus so 2 pi kf Vm cos omega mt by omega m means omega is equal to 2 pi f, so 2 pi f means fm, here omega m, so it is the fm. 2 pi and 2 pi is get cancel, so omega ct plus kf Vm cos omega mt by fm. Okay, so omega ct plus this is kf into Vm is denoted by del f, frequency del f is called the frequency deviation. Okay, kf into Vm is called the frequency deviation by fm into cos omega mt. Okay, where del f is equal to kf into Vm, which is called the frequency deviation. Okay, which is called the frequency deviation. So the modulating, so the FM signal V suffix FM is called Vc sin, okay, sin theta, which is carrier signal is vary according with the modulating signal. So Vc sin, put the value of theta, means omega ct plus del f by fm into cos omega mt. Okay, So Vc sin omega ct plus mf, del f by fm is denoted by m suffix f cos omega mt, where mf equal to del f by fm. Okay, this is the equation of fm. This is the equation of fm. Fm equation is this, where mf is called frequency modulation index. Frequency modulation index, which is the ratio of del f by fm. Del f means frequency deviation. Frequency deviation by ff means modulating frequency, maximum modulating frequency. Okay, so what are the waveform of fm? So this is the modulating signal, this is the Vm, this is the modulating signal, and this is the carrier signal. This the carrier signal is Vc, and this is the FM signal, V suffix FM, whose amplitude is constant and phase is constant. So amplitude is constant and phase is constant. Okay, this is the positive pulse and this is the negative pulse, and this is the positive pulse of the modulating signal. This is the positive pulse of modulating signal, this is the negative pulse of modulating signal, this is the positive pulse of modulating signal, and this is the carrier signal. This is the modulating signal. This is the modulating signal. Okay, this is the carrier signal, and this is the FM signal. What is FM signal? Now the frequencies vary. Whose frequency? The carrier frequencies vary according with the modulating signal. So when the positive pulse of the modulating signal, when the positive pulse is modulating signal, this is carrier signal, means high frequency, and modulating signal means the low frequency. So frequencies vary. When the positive pulse, high frequency. When the negative pulse, this is the positive pulse, this is the negative pulse, this is the positive pulse of modulating signal. When the positive pulse, the high frequency. When the negative pulse, low frequency. When the positive pulse is high frequency. Okay, so this is the positive pulse, means high frequency. High frequency means the carrier signal. Okay, negative pulse means low frequency. Low frequency means modulating signal. This is the positive pulse, means carrier signal. So frequencies vary. Okay, this is the high frequency, this is the low frequency, this is the high frequency, again low frequency, again high frequency. So frequencies change. Amplitude is constant, but frequencies change. First high, second low, third high, fourth low. So frequencies change, frequencies vary. When the positive pulse, the carrier frequency means the carrier, high means carrier. When the negative pulse, this is the modulating signal, because the modulating signal is low frequency. When the positive pulse, the carrier signal, because the carrier signal is high frequency. This is the waveform of FM signal. Okay, where the frequencies vary, and amplitude is constant.